In this video, I'll be covering question 3, part C from the 2018 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. All right, so first and foremost, as soon as I see a graph on an AP Calc problem, I always want to know what that is the graph of. So first and foremost, they tell us very clearly this is the graph of G. But it is also, you'll read in the language of the problem, the graph of the derivative of f. So this is also f prime of x up above here. So that's important to us as we go through this next problem because we're talking about f in this problem. So part C wants to know on the interval from -5 to 6, what open intervals, if any, is the graph of f both increasing and concave up. So when we go through this, what we want to know is what do those terms mean? The word increasing, we have to make sure we understand that that's talking about when we have a positive first derivative. And concave up is saying when do we have a positive second derivative. So that's how we know when things are increasing and how we know when things are concave up. Well, when we come to look at this graph right now, when you read off a derivative graph, because this is the graph of the derivative, you're reading off the pluses and the minuses. You really kind of ignore the shape and you say, okay, wherever this graph has positive y values, that's where the original graph was increasing. Wherever this graph had negative y values, that's where the original graph was decreasing. And then wherever we have these, wherever it hits the x-axis, that's where the derivative was equal to 0. Those are those horizontal tangent lines. So for our problem right now, we only care about where the derivative is positive because we want to know where it's both increasing and concave up. So reading off this graph, we're only looking right now at this portion of the graph because that's the only piece of the graph that includes an increasing piece. All the other parts of this graph, so down here, all this stuff here, this is all where it would be decreasing because it's in the negative space. And then we've got a little bit of section right here, that's all where it would have a 0. So the only part that fulfills the first thing that we're looking for is that chunk right there. So from that chunk right there, we want to know which pieces are going to have also a second derivative that is positive. Well, that means we need to read the derivative off of our first derivative right now. If you go back and think about when you first learned this, when the original graph was your f of x graph, you read off that first derivative data by wherever the graph was headed up and going positive, that's where it was increasing. Wherever the graph was headed down and going negative, that was decreasing. And then whenever it went horizontal, that was a 0 derivative. So you read your derivative off. So to read that derivative, you read where the graph was going up or down or horizontal. We're going to play the same game right now, but because our starting graph is now our first derivative graph, when we play that same game, wherever that graph is going up right now and has a positive derivative, that's a positive second derivative. And that tells us where the graph would be concave up. Wherever that graph would be going down, that would be a negative second derivative, and that would tell us where it's concave down. And wherever it's going horizontal, that would be a 0, and we would look for possible inflection points there. So for us, because we want to know where is that second derivative positive, we are looking for where would we read off a positive increasing section on this first derivative graph. So you would read that off. If I was just going to read this generically, this would all be plus, plus, plus coming through there. Then this horizontal section, that'd all be a bunch of zeros. Then this next section would be going down, negative, negative, negative. And then starting here again, we'd all be going positive, positive, positive. So as we read this derivative data off of our first derivative, that is telling us second derivative information. So on that much of the graph, we would see that this section here, that's where it's positive, so it would be concave up there. This section here, that's also where it's positive, that's where it would be concave up there. So our intervals that would work, we would say starting at 0 and ending at 1. And then we would also have an interval starting at 4 and ending at 6. And so your reason is you would say because f prime of x is positive in those intervals, and f double prime of x is also positive in those intervals. And there you go. You get 1 point for getting the intervals correct, and you get 1 point for giving them some reason. You could also draw in pictures like this. Maybe I would even write down something like that to sort of support all of your work. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.